I am very happy that at least one of us has a handout instead of a PowerPoint, like me, as you will see tomorrow. Tom Nickles is known for his work on heuristics and problem solving and scientific change, and his insistence that we need to relate the history of science to philosophy of science for many decades. If you look at the Stanford Encyclopedia of Philosophy, you will see his article on scientific reduction.
Revolution.
Oh, I'm sorry.
Revolution. Did I write that?
Scientific revolution. That was
My scribbles.
And he has recently edited a book on Thomas Kuhn for Cambridge University Press, and he is hard at work on articles on evolutionary epistemology.
Thank you very much, Emily. And I know it's late in the day. It's been a long day. Everybody's half dead.
No.
This is this is not my best time of the day either. But I'll try to be as lively as I can. So when Einstein was up for a position as a professor, as I recall, both Poincaré and Planck wrote reference letters for him. Here's a good advice for students seeking positions or junior faculty members seeking higher positions, right? Try to get an Einstein or a Planck or a Poincaré, provided they will write a good letter for you. But anyway, they both stressed that Einstein was remarkably sure-footed in strange new domains, foreign domains of reasoning. My title, by the way, is Fast and Frugal Heuristics at Research Frontiers. And I'm going to stress frontier ideas working forward in a prospective direction. I've long been interested in whatever reasoning we can find there, and it's I've been disappointed that philosophers and other science studies people have not given more attention to this. I mean, some historians and sociologists and so forth have actually given more attention than philosophers. And when they have given attention, it's been somewhat disappointing in that they tend to tame, understandably, tame the frontier as much as possible. Even, say, Kuhn in Structure of Scientific Revolutions explicitly said in his introductory remarks and so forth that he was trying to bring context and discovery back into the discussion. But this was mainly, and I think quite illuminatingly, in normal science, which is hardly the kind of radical frontiers he's talking about in the revolutionary part. And later he admitted that he had really nothing much to say about how people got their revolutionary ideas. So I'm not going to be talking about totally radical frontiers. We don't need revolutions here, but we do need frontiers that are open enough that people are trying to come up with transformative ideas and not merely putting dots on I's and crossing T's that are already there. So I find much of the philosophical literature a kind of attempt to extend confirmation theory, which is basically retrospective. You already have the theories or the models on the table, and you're trying to, and you have these sets of data, and you're trying to find out a suitable relation to count as confirmation there, and so forth. So that there was a recent article addressing the problem of new theories by Leah Henderson and Jim Woodward and a couple of other people in Philosophy of Science a few years ago, which they were applying a very sophisticated sort of Bayesian approach to this. And it seemed to me that didn't work very well for a really serious case of new theories. Even though with the problem of new theories, you've already got the theory. I mean, they weren't even wondering where the theory came from or anything. So I've known sort of about this German guy, Gerd Gigerenzer's work for some time, but recently, in fact, since being invited here, I've been reading more of his stuff, and there are thousands of pages of Gigerenzer and his ABC group and so on. He is a psychologist who's head of the Max Planck Institute for Human Development in Berlin. His spouse, by the way, is Rainy Dastan, a famous, well-known historian of science, who has a Max Planck Institute of her own. Anyway, Gigerenzer stresses the importance and the reliability of what he calls fast and frugal heuristics, where by ignoring certain kinds of information, you can actually come up with results that are as reliable as far more extensive statistical methods, multiple regression and that sort of thing, where you have complicated weighting schemes and the like. And his motto is less is more. That often we can approach complex issues in a more simple way than people have thought. So this intrigued me greatly. I thought, frontiers are precisely situations in which often the domain knowledge is very limited, I mean almost by definition. Or there may be a whole lot of information that is very badly organized and maybe conflicting and extremely noisy, so we don't know quite how to handle problems with categorization and that sort of thing that come up already today in discussion. So I thought, I will see what kind of a take Gigerenzer could give us on scientific work at frontiers of research. Unfortunately, most of his examples are medical diagnosis, legal problems, even stock market things, which he talks a lot about uncertainty and the application of this approach to decision-making under uncertainty. But I found that his examples were not as rich and I think probably as deep as at scientific frontiers. So I'm not just scientific, technological invention of transformative kinds, even creativity in any area. It could be music for all of that. So what I hope to do in the future is somehow get together with Gigerenzer and press him on this to see how far his account will reach into basic science and technological innovation of a deeper sort than he's discussed so far as I know. I mean, I have not read nearly all of the thousands of pages that are there, but so far. My early enthusiasm was somewhat tempered as I read. So what I will do, I will present some of Gigerenzer's ideas, look on the positive side, and then give some critical worries that I have. It's more of an investigative project than an exploitative one, that I don't come to any really final conclusions here, just raise a bunch of issues. And a lot of it concerns decision theory, which is not an area that I've done much with. So I would welcome any suggestions any of you have here for this too. A basic distinction that needs to be made is decision-making under risk versus decision-making under uncertainty. A really rigorous approach to decision-making under risk means, suppose you have three action choices. You would have to know, have a complete partition of possible states of the world that would be relevant to these choices, know the probabilities of each, and have well-defined utilities for each, so that you could then multiply this all out, the probabilities of the states of nature weighted by the utilities, and then choose that action that had the greatest expected utility. Often this information is not available. It's very often, and especially at scientific frontiers and so forth, it would be extremely rarely available. And so one is pressed into decision-making under uncertainty, where either you don't know all the states of the world, you don't have a clear partition of them, your domain knowledge is thin enough, you couldn't dream of maybe assigning probabilities to them, or might not even know how to define the probability, or maybe your utilities were not clear at all, and so on. So you're put in a much more precarious situation. And so the question is, whether his work on uncertainty and so forth provides some halfway serious illumination for the frontier situation. So, roughly speaking, turning to the handout, I'll stick fairly close to this, partly because it's late and I'll probably get all tangled up myself if I don't. But so he and his group, I'll call him G after this in the notes, the ABC group, the Adaptive Behavior and Cognition group, there in Berlin, provide examples of simple, weak heuristics that operate on surprisingly limited databases to return results that are as reliable in some contexts as standard, far more expensive methods, especially under conditions of uncertainty. And he sees this as a continuation of Herbert Simon's program of bounded rationality, satisficing and heuristics. Herbert Simon was that polymath who, back in the 40s, wrote a book called Administrative Behavior, saying, you know, traditional neoclassical economics which requires all this rigorous form of reasoning, it can't possibly apply to people in actual business situations. And so he introduced the idea of satisfying, in which you basically set an aspiration level and then stop searching the moment you find some option that meets that aspiration level. And if you don't find one, then you maybe lower your level slightly and try again. But anyway, there's a stop rule. So you don't waste all your time looking for the optimal solution, which may or may not exist. So it's the idea that optimization is not always the best way to go. It's often not possible. And even when it is possible, it still may not be the best way to go because it's too expensive. Because it's a kind of, I regard Herbert Simon as one of the great pragmatic thinkers, actually, a great pragmatic philosophical thinker. And that in this kind of research or in business decision making, that he was originally concerned with good enough is good enough, and to get you on to the next step. So don't waste a lot of time and effort, which you don't need. Now, here's an important point about Gay-Gorenzer's approach. A lot of people say, yes, we must resort to heuristics either because optimization is not possible, or even though it's possible, it is too expensive. But heuristics are second best. Gay-Gorenzer's breakthrough was discovering some cases, at least he claims to have a number of them, in which using heuristics actually does as well or sometimes better than the full tilt optimization programs. So he rejects the view that taking a heuristic approach always involves a trade-off of accuracy versus effort. That in order to substantially decrease your effort, you're also sacrificing accuracy. So sometimes less is more. You can actually get as good or better results from ignoring certain kinds of information, taking the easier way out. Well, there are, let's see, what do I need to aim for as my stop time? I really didn't check my watch.
So you began at 4 to...
Okay.
So we have 40 minutes. It means
So around 25 till or so, I stop, something like that?
Yeah.
Okay. Well, I will cut this next section short. I think there are, by now from some other talks like Carlo has just concluded, some obvious connections of this to modeling and science. Gay-Gorenzer puts his program in historical context. He says basically there are three basic models of inference for explaining and predicting nature: deductive Laplacian demonstration, a probabilistic model, kind of Enlightenment type revolution, and now Simon's heuristics. We think even deductive logic systems, insofar as they're rigorous, are models, because we know a lot of human reasoning, or some human reasoning, is not captured by the subtle semantics of it and so forth. But Gay-Gorenzer wants to stress ecological rationality, something he calls, after Simon, ecological rationality, and that is things that may look non-rational or even irrational from the standpoint of standard probability theory could be perfectly reasonable in certain contexts. So he says it's got to be context sensitive, and rejects the idea of taking a priori abstract probability theory as a norm of rationality, a sort of absolute norm of rationality. Says it's got to be relative to context. So, say in relation to Tversky and Kahneman's heuristics and biases program, he says, Simon, by the way, was quite enthusiastic about them. Simon deliberately left his program of bounded heuristics and satisficing open to further further development. And Simon was quite enthusiastic about the Tversky-Kahneman approach because it was behavioral, it was heuristic, and so forth. Gigerenzer takes a further step and says, yeah, but he opposes them. He says he has several objections, but one is they're still taking sort of standard a priori, standard probability theory as the absolute norm here, rather than being contextually. Oh, so in the Linda Bank problem, for example, or all of those cases that, and as some of you know, even experts have critiqued Tversky and Kahneman on these as to whether they're really irrational. That it might be quite reasonable. I mean, if you're wondering who to go to lunch with, you might not want to go with Linda the banker, but you might be more interested in going with Linda the philosophy major who was a social or is a social activist, and so forth. So anyway, that's his claim that he goes beyond Tversky and Kahneman in rejecting the idea that there's just one size fits all when it comes to rationality here. So he's introducing a new context-specific conception of rationality. Methods themselves are specialized for specific contextual applications. As such, they embody knowledge. So a brief quote, heuristics at their core are models of the cognitive process, implicit models in a way. And so this ties in with, I think, something Lorenzo was saying this morning, this Lorenzo in the window. The famous painting by Leonardo. Lorenzo, you look in these Finestra? Okay. This is half right, I think. Models can be regarded. Methods can be used as context-specific methods as implicit models, insofar as they're useful of the cognitive processes involved. But on the other side, as Gigerenzer himself and Simon emphasized in other contexts, they're also implicit models of the environmental context in which they can be successfully used. Simon talked about the two blades of a scissors, one blade being sort of human cognition, the other being the environment, and you need both blades in order to make beautiful sort of scientific or creative music here. I don't know where, I use a crowbar, a pry bar metaphor myself, and I don't know where I got it from. But the idea, I tried to think maybe sort of like you physicists do, find thinking of methods as tools, find a very simple tool as a kind of model of method. And so my model of method is the crowbar, which works only insofar as what? It fits the world at one end and the human hand or the human capacities at the other. So really, successful models are bridges in that sort of way, in that they implicitly at least model two domains together. The capacities of the user and the environment. There's some compromise involved typically, and so this perhaps is a non-realist element of them. On the other hand, the fact that they get any purchase at all within the environment suggests that there's a kind of implicit realism here too, to some degree, that they capture something. So, for example, if the world is tomato soup, a crowbar will be absolutely useless to you. You can't get any leverage on anything, right? And if we are fish, the crowbar is also useless because we have nothing to grab onto it with. So that's what I mean about the crowbar model, the metaphor for method as a tool. Okay, let me say a few words about what I see as the problem of understanding research at frontiers, trying to deepen fairly briefly, since time is limited, what's going on here. Then I'll say a few words about Gigerenzer, a few more words, and illustrate some of his heuristics, and then pass to some positive and negative comments on it. So, pretty clearly there are many different kinds of frontiers, some more serious than than others, but generally speaking, domain knowledge is quite weak in a frontier. As I said a while ago, if there is a lot of information, it may be very noisy, very badly organized, conflicting, and so forth. Thinking of frontiers, it may help to think of some recent results that are still undergoing interpretation, but by David Wolford and William McCready, called the no-free lunch theorems, which is roughly, very roughly stated, when averaged over all possible universes, no method turns out to be better than any other. So that means, insofar as our frontier is new, insofar as we're encountering a new world, so to speak, we can't rely with total credibility on methods that have been successful in the past. So we're always facing serious new problems of finding methods that will work there. Think of the development of theoretical ecology in the 1960s. By MacArthur and Wilson and people like that, island biogeography and so forth. Before that, ecologists were people who tramped around trying to find new species of butterflies and things like this. And so they were trying to provide mathematical models for ecological systems. Well, there was no guarantee that you would be able to make useful progress here at all. It turns out, I think ecologists today would agree that through a lot of trial and error and so forth and so on, some fairly serious results have come forward. But that's an example of a sort of new world where you can't just fairly automatically extend methods that have been successful in the past in other domains. So that's one thing to keep in mind. Turning to the points here, number one, very bottom of page 1. The sparser and more badly organized available domain knowledge is, the wilder the frontier, other things being equal. Number 2, thus reasoning in frontier contexts involves a good deal of decision-making under uncertainty, often extreme uncertainty, and not merely decision-making under risk. Gigerenzer's complaint, which, again, I've not been deeply into decision theory, but it seems to me this is probably accurate, is that too many people make the jump from thinking, well, we have a pretty good handle on decision-making under risk to taking on domains that are really under uncertainty and not dealing sufficiently seriously with them. There, even the problems are ill-defined. I could give you some nice quotes. Hans Reinberger, for example, in his book on the epistemic things, has some beautiful quotes on the uncertainties of experimental systems and so forth. When you, just for example, but I will skip those in the interest of time. But item 3, roughly in basic science, there's an inverse relationship between problem-solving power and domain knowledge. It turned out to be the case in computer science. There, Feigenbaum and Newell and other prominent developers of early artificial intelligence came to the realization that the completely general domain-neutral heuristics of the kind that Herbert Simon himself originally championed, backward chaining and things like this, where you didn't have to have any specific domain knowledge, or not very specific at all, resulted in a very weak problem-solving power. To get problem-solving power, you had to inject serious domain knowledge, and so there was this fascination with so-called expert systems, where you try to get the expert knowledge of doctors and medical diagnosis, or bankers and whatever, and so on, and incorporate that into computer programs, and later just sort of knowledge-intensive computer programs of various kinds. So this is bad news at the in frontier situations. Domain knowledge is weak, and so there's only you're very limited as to what you can do in terms of powerful methods that have domain content, or insofar as you do use such methods, you're taking a large risk, assuming things about the domain that you really don't have much basis for knowing at that point. Science progresses, it undermines what went before. Again, I think this is largely true. There's a tendency on conservative philosophers, even philosophers of science, to see fields as stable and still relatively cumulative. But I think about, say, biological evolution. you don't need Kuhnian revolutions. Biological evolution with changes almost imperceptible from year to year can result in a long, with a change as great as you want if you wait long enough. And so I think even quasi-normal science is like that. And Kuhn himself, I thought, even too tame the conception of normal science. Some fairly ordinary discovery that we think is nothing, no big shakes, could actually, through reinterpretation, but multiple times, turn out to be quite a radical breakthrough. I could give some examples. So I think the development of science is highly nonlinear, and so this idea that you're facing ever new frontiers, even in mature sciences, as long as there are live research centers of activity, you're going to run into this frontier problem. Okay, I guess I've already said that then, number 5. And let me then go to section 3, Gigerenzer's fast and frugal heuristics. Just basic conceptions, and this is somewhat redundant because I just pulled things from different ones of his works. This is not a criticism because this could easily be cleaned up, I think, but by heuristic he means a computable decision procedure that is fast and frugal. Computable means basically there are going to be 3 parts to it. There's a precise search rule, a decision rule, and a stop rule. At that point, tell you this, you've gone far enough, stop the search. Fast means it can be executed quickly in one or a few transparent steps, either consciously or unconsciously. Frugal means that it deliberately ignores available information, that there are no 3 parameters that you use to fit past data. He's worried about the problem of overfitting by using extensive multiple regression techniques where you've got 3 parameters and you can start attaching weights to this and this, and says those things can do a very good job of fitting past data. They tend to then do a poorer job predicting future data. He calls his heuristics biased in the sense that they build in information about environmental structure in which they work well. Although he's not claiming then that his heuristics are a broad band. They tend to be more or less domain specific, and he doesn't claim that they're always better than standard statistical methods. It just depends on the context. But he says in many cases they do as well or better. So let's see. I've already said some of the rest of this, so I'm trying to save some time here. He also has a goal of psychological realism. Maybe not total realism, but he says the trouble with other methods, including Tversky and Kahneman, is they don't tell you anything about the psychological process involved, just about the, they do, I guess they do tell you a little bit about the biases, but not enough. And he's very much against the sort of as if theorizing that you get a prime example of, say, in Milton Friedman's economics, where as long as you get the right results, it doesn't matter whether the actual economic agents can compute things this way. It's just it works in that sort of way. So he wants a quasi-realistic psychological process account, and he thinks these heuristic rules he's talking about provides it. By bringing in the environment, he says basically, a little quote here, loosely speaking, the heuristic lets the environment do much of the work. So by having the heuristic loaded with some environmental structural information, the bias, it enables the computational part to be cut way short in many cases. So that's the way that works. Herbert Simon had this thing about the ant in his earlier work, that we watch an ant walking on a beach, it looks like it's following a very complex path, and so it's going to take a really complex behavioral theory to explain the behavior of the ant. And Simon says, not at all. We just have to take the environment into account. The ant's response to the environment may itself be quite simple, but once we bring the environment in, that's where the complexity enters. And Simon himself later extended this to human behavior, I think, overextended it. I think human behavior can be quite complex, actually, but Simon once said in that little quotation near the bottom of page 2, human beings viewed as behaving systems are quite simple. The apparent complexity of our behavior over time is largely a reflection of the complexity of the environment in which we find ourselves. Okay. So I've already mentioned the biases loaded into these rules. Another way of, I think, putting Gigerenter's approach is he rejects the view that you can make a non-Kleinian sharp separation between the analytic component, sort of the pure, abstract, neutral, domain-neutral probability theory on the one hand, and then factual information that you plug in. His approach is to use rules that are themselves domain-specific, in effect containing domain structural information, and thereby greatly reducing the computational problems that the agent would have to face. So he claims to be putting forward an approach that's more naturalistic in several respects. I'm now at the top of page 3. Descriptive studies of real people in real contexts versus a priori work, or restricting oneself only to very artificial laboratory situations, or restricting oneself just to computer simulations using models. He's in favor of all of these approaches himself, but he wants to study, as Simon did, real people in real environments. So there's a big analog to behavioral economics and so forth going on here. He wants to extend that approach more widely, basically. It's realist, as I said before, and it attempts to provide a quasi-realist versus a merely as-if account of what is going on. So, you could say, we can explain the behavior of frogs jumping from one lily pad to another, or the baseball center fielder going back, catching a fly ball over his head, as if they're doing very rapid differential equations, solving differential equations very rapidly. But this is ridiculous, because they're not seriously doing that. We can get the right answer, but that doesn't inform us anything about how they do it. And so he wants to have a line on how they do it. So he sums up his approach in terms of those 3 items there. His emphasis at risk is not the same as uncertainty, so don't pretend that it is, the way too many people he thinks do. Rules of thumb are not automatically dumb. They can be dumb, of course, but they're not automatically dumb. That in an uncertain world, simple rules of thumb can sometimes lead to better decisions than fancy calculations do. Less is more. Complex problems do not always require complex solutions. Look for simple solutions first. So if this works, it could be a tremendous reduction of dimensions in complex situations. So some examples. And by the time I got to his examples, I'm beginning to wonder, is this going to illuminate scientific creativity at frontiers or not? So anything is potentially a fast and frugal heuristic as long as it has a stopping rule that limits extended, expensive search and is reasonably reliable in certain contexts. The simplest rules will provide only one reason or a criterion to trigger the decision. Others will have a few more steps, but not too many. His breakthrough came when he gave a survey to American students about German cities, giving them questions like, which of these 2 German cities has the greater population, or to German students about American cities. And he found out that some students knew too much. If they hadn't really heard much about one place, they would pick the one they heard of, and this worked very well in this sort of case. So German students who were sort of in between those who knew a lot about American cities at one extreme, and those who knew almost nothing about American cities at the other extreme, the ones in the middle did very well. So ask the question, which has the larger population, Detroit or Milwaukee? They had heard a lot more about Detroit, so the recognition heuristic kicked in, and they would choose Detroit. And by and large, this worked very well. They did surprisingly well. And this was a kind of revelation to him, and he's since followed up with lots of other studies of that kind, including stock market choices and so forth, which do better on the whole than most experts, highly paid, hundreds of thousands of dollars salary per year and so forth, experts do. So this is what led into the less is more approach. So here are some other possible heuristics. The recognition heuristic we've already met. Given a choice of two things, if one is more recognizable than the other, assign the highest value, whatever the question is to it. Another is take the first, go with the first guess or hunch that comes to mind, or take the last move that you made to solve a problem. Take the best. Here's one that involves multiple steps. So given a set of cues, order this value, start with the first cue that makes the relevant difference. Go with that cue. Two cues are tied, then go to the next in order, and so forth. So that's the way it's supposed to work. On a larger scale, they are wary of the so-called tools to theories heuristic for reasons already indicated. These usually lead to as-if theories where if you look at research in, say, perception and a lot of other places, psychologists will figure out ways using sophisticated mathematics and so forth to explain why people see things the way they do, and then attribute these theories to the people themselves. So it's Richard Gregory and that tradition from Helmholtz to the present basically says, well, human beings are like little scientists. It's like you have a little community of scientists in your head who are very rapidly forming hypotheses and testing them against the data coming in. I'm not myself judging whether that's correct or not at this point. Just that would be an example of the kind of thing that he's leery of. Okay. Well, yeah. So there's some good news and some bad news. And I've not completely given up on Geiger-Inzer here, but the bad news tempers the good news, and I'd be interested to know what you think. So to accentuate the positive, at the very least, Geiger-Inzer's approach leads us to ask whether and under what conditions less could be more in innovative research context. Anything we can learn about how to improve research efficiency, of course, would be more than welcome. The fast and frugal heuristics, in no formal sense, thrive in an uncertain world by default. Optimization methods are rarely applied. That's what he claims anyway. They can be as good or better. I've already said that. Evolution. This is another naturalistic strain in his approach. So evolution, the most impressive design enterprise we have, basically, arguably relies heavily on fast and frugal heuristics, proxies, and so forth. Fish that just go for a red spot, or birds that feed just from an open beak. I mean, one cue triggers their behavior, which naturally can go awry, but in that particular environment that the bird normally finds itself in, works very well. Much better than some extremely expensive biological process that would require much more neural energy, so to speak. These heuristics can be innate, gotten by evolution, or learned. That really doesn't matter. Each way is a form of learning. And the approach works reasonably well up to a point with Kuhn's idea, and I find this maybe the most the most interesting possibility there. Kuhn, way back in structure, said the way scientists solve problems is by trying to model them directly on exemplary problems already solved. And in common law forms of legal systems, the same is true. You try to model your present legal situation on published legal decisions in the past. However, we know Kuhn himself rejected rules as a basis for this, and that can lead to some issues that I'll mention in just a moment. Major changes in the methodology of science itself, the kind that Carlo and others have mentioned, in a way, end up relaxing standards, resulting in a more quick and dirty way of doing research. So that from an old point of view, the method of hypothesis, for example, was dangerously risky, yet we think it the use of models in general. In fact, one question I have is whether Gigerenser's view can be extended to models in more generally. Come back to this right at the very end. But first, just some frontier difficulties, overlapping difficulties. My time is fast running out. Do we even need rules? I mean, a lot of people would question whether we even need those kinds of rules. I mean, isn't it basically just going to be a biological process of development, at least if you have any kind of reductive tendencies at all? Ernst Mayer's 4 causes for why the bird flew south, when a certain weather front came through, and so on. Are his heuristics of any real use at frontiers of research? Most of them are pretty low level. Most of them seem almost common sense in a way, sort of disappointingly low level. But my take on there is to question myself: why did I think this was so exciting in the first place? Why should we think necessarily that we're going to find some really clever trick in methods that are going to provide the great secret of scientific creativity? This, I think, is a throwback to an older conception of the scientific method, that there's some special logic or special secret there that somehow scientists get in on that other people don't. Because in context, most of these kinds of heuristics come down to common sense, if you have any sense of what the domain is like at all. One can raise the regressive rules objection. Gigerenser, against its first in Kahneman, he says just give vague labels to their heuristics and biases program. The representative heuristic, the accessibility, what they call it, not accessibility, but something like that, recognition heuristic, and so forth. Gigerenser insists that they be computable, so he wants to formulate them as rules that then you can run on a computer in a computer program. But that already, that's already a form of human modeling, perhaps. Maybe he'll reflect what's going on in nature. Then there are problems with the bias issue. In scientific frontiers, again, domain knowledge is thin. How can we determine, except by some form of trial and error, what biases need to be built into our rules? Is there anything really really new here? In all the cases that Gigerenser touts as successes, we know independently what the right answers are. Which cities are bigger than which, and retrospectively which stocks did better, et cetera, et cetera. But in the domain, in the frontier, we're not going to know this. And so again, I have trouble seeing how this is going to be applicable there. Or in terms of ecological rationality, that it works in this domain because it somehow reflects the domain structure. I mean, how can we tell that either, except retrospectively? So in terms of prospective help in understanding, thinking in frontier situations, I have some problems there. I'm going to have to draw it to a close. The point about models. Insofar as you could regard models themselves as sort of glorified heuristics, and insofar as Gigerenser has anything really to tell us here, this could be another way in which models are independent of theory, in that you could regard the So one could relate this to stuff that James mentioned earlier about Nancy Cartwright and others as well. But I'm going to have to cut it short here, and I'll be over time. So thank you very much. So my message is very mixed. My early enthusiasm is somewhat dimmed, but I would invite your suggestions of what I look at. Yeah, Richard first, and then you.
Yeah, I think it's an interesting question, whether, if so, why so much less profitable in research frontier cases to have this fast approval strategy. Actually, I would think there is one difference that seems crucial to me and that may be relevant here, and that is that in research frontier situations, the most interesting thing tends not to have an actual answer to the question, but to find a research strategy to understand what we need to know in order to give a good answer. And it seems to me that the Gigeren's examples don't tell anything about that. So one idea might be that for that reason, in research frontier situations, that's not what you want to have, because those fast and frugal answers, they may be right and better in the short term, but they don't tell you where to go and what you need to investigate further in order to get better answers.
Yeah, no, I don't disagree with that at all. One part that I just had to leave out completely is we know that even in foreign domains, experts seem to be more successful than amateurs up to a point. Although there's that phenomenon that Kuhn and others called attention to people changing fields, not being deeply embedded in the culture of that field and its conventions, its restrictions, and so forth. And one thinks of it, Max Delbruck or even Schrödinger moving into the biology area, and so forth. But yeah, I think I basically agree with you that I just didn't find much grab in the kinds of heuristics he was providing, or the kinds of examples he was providing. So it seemed that even though he talks a lot about uncertainty, it wasn't really the rich sort of uncertainty that people that doing basic science and even technological frontiers are needing. I think you had a...
First one was sorry, then
Okay, here's a question. Okay. So I think you say this in more or less in your bad news, but just in different words, as a question of basic motivation for thinking that G's ideas would apply to, say, frontiers of physics. It's easy to see the evolutionary motivation for thinking that fast and frugal heuristics work for fairly mundane reasoning. When we move to something so far from common sense as you have in modern physics, say the kinds of heuristics that are now needed in quantum gravity research or string theory, what have you, I'm not quite sure if I see even the basic motivation for thinking that the success of G's fast and frugal in the mundane context would have any bearing whatsoever.
Yeah, in the case of biological evolution, you think, well, there are hundreds of thousands and millions of hundreds and thousands of generations by which the organism has been tuned to the environment, basically by a trial and error process, so when it comes down to the bottom. Whereas the human frontier research context, the whole idea was we wanted to get beyond that, do something more efficient, and it's just hard to see. The wilder the frontier, I think the more you're pressed into something like trial and error until you get enough domain knowledge from, and it's not working, but here's a constraint on future work. So, and I agree with you. enough on gigahertz yet, but, you know, I hope to talk with him in this group.
Yeah, so just a simple point. So when Gigahertz was presenting those fast and approval heuristics, there is this emphasis on the fact that they are domain specific, right?
Mm-hmm.
So,
Yes.
well, but then I was wondering, okay, so let's grant this point, they might work in specific domains, but then isn't the problem with the fact that we need a fast and approval heuristic to find out those domains in which they work, right? So
Exactly. Yeah,
reiteration.
That's the point I tried to make here, but everything got very rushed at the end. Absolutely, yeah, the frontier context is precisely what you don't have.
Yeah, exactly.
Yeah, you don't have any, you know, I mean, he as an investigator can stand aside and test the reliability of different heuristics in different domains because he knows the answers already, but real frontiers being like that.
Lorenzo. Yeah.
So thanks. I wanted just to add good news about
We could use
this
some.
problem of heuristics. And the good news are that you already know that there is a program in logic that is proposed by John Booth and also supported by Gabay that is naturalization of logic. So in this case, there is the problem that is similar to the one of the heuristics, to recognize that the so-called fallacies not always are bad, because they present what the logician called a kind of material validity. Sometimes they preserve truth, they work. And one example is abduction. That is the fallacy of the affirmative consistent, but it is very eco-cognitive fruitful. So the problem is that Aristotle said that deduction, syllogistic deduction, is the derivation from premises by necessity and without the intervention of anything external. But you can also open this idea of logic and to think to a kind of logic, of deductive logic, of deduction, that is more eco-cognitive sensitive, like in the case of these Gigerenter's heuristics and so on. So, in conclusion, the good news, there is more interplay between the analytic method and deduction, the tradition of deduction, the logical tradition, than expected. Because there was not only artificial intelligence that first built rational programs, because they are based on algorithms, to reproduce this kind of reason. For instance, diagnostic reason. There is a field in machine discovery that is called machine learning, that is called machine discovery, where they build programs that make new scientific discoveries, also published in scientific journals in an automatic way. But there is also a program of making more deductive systems that are able to reproduce in a deductive way these kind of reasonings. And in the case of abduction, we already have a lot of non-classical systems that are deductive systems that are able to make abductions. Okay, so this is
at a high
the good
level,
news.
you know, the overall history of development, our ideas about scientific method of somewhat vindicated a fast and frugal approach, as I say. You know, the Baconian induction was much too labor intensive in certain ways. And the method of hypothesis comes in, contrary to hypotheses non fingo and so forth, that greatly sped up research in a way, and in sparse domains. One did not have to have a Baconian database on which to work. Now one can propose hypotheses and use the hypotheses themselves to guide one to very specific and perhaps very scattered predictions. And so it was a very fruitful development. The emergence of a modeling where one doesn't even have to suppose, contrary to the method hypothesis, that your hypothesis may be true. You know, the model is false from the get-go, technically, but it can still be extremely truthful. So there's, you can regard that as a kind of at a high level, fast and frugal move, and I think probably everyone here would agree that modeling practices have been extremely fruitful across the sciences, to the degree that there are some sciences that have models all over the place, but it's not clear what you would call a theory. So this is what I was gesturing toward when I suggested that there is a line of thinking here that would make models independent of theory. The models are not derived from theory. I mean, the models are roots to theory if you need theory at all. You might just stick with the models for different things, being biological sciences, neuroscience, and so forth. I think this is often the case.
Yeah, May. Yes, so,
Sergio.
I want to go a little bit deeper into this evolutionary metaphor that's used sometimes. So, as far as I understand, of course, the world outside is ever-changing, and in some sense, biological beings adapt to the world, and this is possible because changes are there but are not so dramatic.
Correct.
So, if the world were changing dramatically, there would not be, in my opinion, a fast and frugal strategy of survival.
Yes,
So-
wipes things out.
Yeah, if gravity changes with time in a dramatic way, no dog would be able to catch a flying ball. So he adapts and knows because he has experience this as a result of the empirical experience that a ball follows a trajectory that is computable without solving differential equations. But if gravity was changing with time dramatically, no way out but solving differential equations. So in my opinion, with this fast and frugal heuristic is more or less like that. If I am in a situation where I can somehow adapt, because changes are there but are not dramatic, then this approach might work.
Yeah,
But if not, I have another way but being...
I sometimes think my own early expectations were a little too high for, and I mean I myself, I don't know, some people, I'm old enough to have known and had courses with Kuhn, and so people think I'm automatically, so I've been asked to write all these papers about Kuhn. But I think he overdid it on scientific revolutions and so forth. That often, I think he was also, I think his normal science is too tame and his revolutions are too revolutionary. I think there's a middle ground where one finds, early in life I studied the early quantum theory. It was a very fascinating transition where some of Kuhn's points seem to apply there, that people are recycling old methods of problem solving with some crucial changes. There are, as some of you have spoken earlier today, borrowing, starting with James this morning, borrowing some things, only then adding things like quantization rules and things like this to in the process, so that one can find some strong continuities even there. I mean, after all, if there was a big enough break, it would be unintelligible to the community.
Yes,
and so
exactly, that's my point.
I mean, Kuhn himself makes this point in terms of this essential tension between innovation and tradition. That you can't totally abandon tradition. You can't do a scientific, you can't do a French Revolution in science and expect to
Yeah,
to
of
get
course,
it.
we recognize afterwards that there is a degree of ingenuity, but nonetheless, the changes which we call revolution still were.
And some developments that
Yeah.
what I meant by nonlinearity is, some developments that look fairly ordinary to people of the day turn out to be have all kinds of implications that again, this is uncertainty. I have no idea what it could lead to in the future. With the head of the Linnean Society in 1859 in England wrote this annual report saying, I think we can safely say that there's no major contribution comparable to Wheatstone or Newton. His choice of the juxtapositions there is a little strange to us, when in fact that was the year that Darwin published his paper in that very journal. My favorite example is Planck 1900, using his resonators and doing a kind of trick to get the to get the right black body distribution law, the empirical law, with a kind of theoretical derivation that eventually went by the board. And in 1905, when Einstein and Ehrenfest thought that Planck was trying to solve the ultraviolet catastrophe problem and sort of reinterpreted his work, and Einstein soon was drawing conclusions that in high frequency limit, his particle life, Planck himself rejected that, for years. And then you go all the way up to 1924 with wave particle duality, Einstein-Bose statistics and all of that, and you can see implicitly, retrospectively, all of this stuff was packed into the very different limits of Planck's empirical law. And at the time, it just looked like one more empirical law like many others that had been discovered. So it could find many cases in science like this, I think, where it gets reworked, reinterpreted, new implications follow. And this takes great cleverness. It's not just automatic deduction by turning a crank. So I think we need to avoid radical revolutions, and yet I still think it's generally true that philosophers have used overly tame conceptions of